Good day, ladies and gentlemen. My name is Michael Pareja, a master's student from the De La Salle University, Manila. I would like to share our research paper entitled as the Fuzzy Irrigation System with Rain Detection and Fertilizer Control. With increasing water scarcity and increasing demands for water usage to meet agricultural needs, an irrigation system's automation will take place. The irrigation system can use only the amount of water required for each portion of the landscape rather than overwatering. This system may also refrain from watering with the necessary sensors if the soil is still damp due to recent rain. Not only does this protect natural resources, but it can save money on water bills as well. In the methodology, so we have the system model and the fuzzy logic system. So let's proceed with the system model. So this framework is divided into three models that can help regulate and track water supply and distribution, including the rain detection model or RDM. So it uses an optical rain sensor RG11 to detect the presence of rainfall in the area. And also, this sensor uses the same sensing concept in millions of windshield wiper controls for automotive rain sensing. In RDM, it has two indicators that manage and save water for the system. First, if there's rain, the system model will not operate for irrigation. However, if no rain is approaching, the system will automatically irrigate depending on the three input parameters condition. And then we have the FCM or Fertilizer Control Model. So this model operates a system of sprinklers in the crop fields. So the sprinkler system releases fertilizer fluids that enable the farmer to achieve an optimum result. So it is a profitable crop using a minimum amount of water and fertilizer. And also, it cannot work daily because it depends on the fertilization schedule of the plants. If the consumer switches on the irrigation system, the FCM will open automatically. And then, in an FM or fuzzy model, an automated system consists of hardware and software infrastructure that functions as a system for the operations of a controlled environment. The system model uses fuzzy logic to track state parameters, compare state parameters with target output, choose the desired outcome to change the current system's condition, and execute the appropriate behavior. To construct a fuzzy control system, it is crucial to define the three inputs that help the generation of fuzzy rules for determining the time of irrigation. The first input is the soil moisture, followed by the soil temperature and the water level. In soil moisture, we have the three levels. First is the wet level that ranges from 0 to 20 centibar, normal level from 10 to 40 centibar, dry level from 30 to 60 centibar, and then in our next input is the soil temperature. We have the cold level from 0 to 20 degrees Celsius, mild level from 15 to 30 degrees Celsius, and then lastly, the hot level from 25 to 40 degrees Celsius. And then, water level, we have the three membership functions. So, first is the low level from 0 to 2 meters, normal level from 1 to 4 meters, and high level from 3 to 6 meters. Our output is the time duration. It is a fuzzy output that contains three possible results, such as the short time level from 0 to 60 minutes, medium time from 30 to 120 minutes, and then long time duration from 90 to 180 minutes. And then this table, the fuzzy rule system, it shows the 27 rules generated based on the free system input parameters, such as soil moisture, soil temperature, and the water level. The decision taken by these inputs may identify the output data for controlling the relay on or off. Okay? So, in our results and discussion, the MATLAB Fuzzy Logic Designer or Fuzzy Inference System was used in the simulation process to determine the expected outcome of the proposed system. Three input parameters were considered to decide on the provision of adequate water for crops. For soil moisture, the crisp input range is 0 to 60%, soil temperature 0 to 40%, and the percentage range of water level is 0% to 6%. So we have 4 testings or 4 simulations. Okay, so we have test 1, test 2, test 3, and test 4, and then the first bar is our soil moisture, second is the soil temperature, and then water level, and then our output is the time duration. Okay. Based on the 3 FSO diagram, okay, the water level associations, soil moisture, and soil temperature are directly proportional to the output of time duration. This can be observed that when the inputs increase, the time duration also increases. If the inputs decrease, the time duration also decreases. Okay. In our conclusion, considering the use of a fuzzy algorithm, an automated system can improve the irrigation process. 3 input factors such as soil moisture, soil temperature, and water level are used to formulate a decision about the amount of time the crops are watered. Moreover, an additional aspect of the device is the rain detection and fertilizer control model. To evaluate the device's efficiency and precision, the MATLAB Fuzzy Logic Designer was used to test and simulate the input data. The findings shows that the fuzzy mechanism has proved its validity in increasing the efficiency of water use during water shortage conditions. And more features such as sensors, image processing, and software technology implementation to enable irrigations that are considered to enhance the device for future work. That's it. Thank you very much for listening.